Okay, so now just moving on to machining this side. The first side, we're gonna first start out by um, showing how to machine this contour using dynamic milling and a standard contour operation. Um, for the actual machining, we're gonna end up using OptiRough, and we'll show later on why it makes sense to use OptiRough. But just to show you how to use dynamic milling, so we'll go into that. So first we need to go into stock setup to set up our initial stock. So we want rectangular stock, and um, we need to specify a bounding box. So we're actually going to click bounding box, and we're going to just make a square around the whole part. We're going to end selection, and we see it gives the auto dimensions the stock body. So we're just going to put check mark, and then we need to tell it where the origin is. So I'm not actually sure where exactly it'll be. I think just based on like the positive y, x, and z, I think it'll be over here. And we just need to also specify that this is going to be at the point 0, 0, 0. So we're going to select the origin and we're going to put check mark. And we can see that it put a bounding box, which is this is the red dash is the stock model. So that's good. It's enveloping the entire part. So now we want to start with a dynamic milling operation, which is this one. So now we can select what we want to machine. So we're going to select this face, and so it'll machine whatever contours and all the material up until this face. So um, check mark, and let's just see what happens. So we have a problem, um, and so I actually ran into this before, so I know why it's giving me an issue. Um, and the reason is because I don't know what this is doing, but the reason is because we need to move our tool plane into the same um, coordinate system as our world coordinate system, or it's going to give us issues. So we're just going to do this. So right now the current tool plane is the top view. Um, I don't know entirely like how that works exactly. I haven't figured that out yet, but I just know that that was causing problems. So you need to keep it in the same plane. So now we're going to go back to toolpaths, and we're actually going to delete this because we can actually see world coordinate system top, and then T plane, which is the tool plane, is front. So we're going to delete this. I'm going to try it again. And so here we can see now that they're both top. So we're going to select this plane, check mark again. And we just want to see what happens. So we can see these lines show the toolpath, and we can actually simulate this. So first we need to make sure that it's using the right stock. So it is. It's just using the stock setup. And go check mark, and then we're going to verify, and we'll see what happens. So that's pretty good. Um, we can get rid of the tool, so we can see this isn't that important um, because this will be machined off later on. So we can just pay attention to this. So you actually get pretty good surface finish on the part. So we're going to play around with some of the parameters. The tool, it's using a 3/4 inch. We are going to change this to a 3/8 inch tool just to get into that radius a bit more, into that like yeah the radius of the contour. So we're gonna use a 3/8 inch instead. We're gonna do radial chip thinning, which is something you want to use for dynamic operations. And then we're gonna just input some standard parameters, so like 200 surface feet per minute. Actually, we can change to 300 feed per tooth. We can change to 0.008 thou. Plunge rate is the percent of the feed rate, I think, that it uses to plunge material. But actually, I don't think that's applies to this. But we can keep that. So we're running at about 3,000 RPM, which isn't that fast. And stock, we don't need that in this case. Cut parameters, we're using climb milling. Tip compensation, so we can change the first pass just so it goes into the material more smoothly. So we can offset it by 200%, and this is a percent of the tool diameter. And then we can feed it at 75% of the um, stand of the feed rate that we specified over here, this feed rate, and then step over. So that's how much it steps in the radial direction. So we want to actually keep this somewhat low because dynamic toolpaths, they take advantage of the chip thinning and they reduce chip load on the tool. So we want to actually keep the step over pretty small, and usually the step down is a lot larger value than traditional machining. So we want to keep the step over less than 25% of the tool diameter is like a general standard for that. We're going to keep it at 15%. And then minimum toolpath radius, that it's if you're machining like corners, that's like kind of controls the radius of the corner. In this case, I think 10% should be fine. There is like that. We can see it over here. This part, we should make sure we get, but I think I think that should be fine. We'll also use eventually a contour to clean it up a little bit. And just to start out, we're going to do 0 just to see what kind of surface finish we get on the part. And then we'll see that it'll be better with a contour pass. So, and then the micro lift distance is it for like small back moves. The tool will lift off the part this distance, and that's like in order to clear chips off the part and minimize tool heating. And then the back feed rate is how fast it moves when it's not on the part and it's going back. So we're going to make this 200%. That's the red line. And then it's lifting off 10 thou, which is fine. And then if it's a bigger moves, greater than some gap size, we can say if it's has to avoid a boundary, which is if there's like something in the way, then you can retract the tool up and then before you move it around. So if you do this, I think everything else should be fine. We don't have to worry about that. Depth cuts isn't an issue. I don't think anything else here applies. So we're just going to keep it how it is. And it should be fine. So we're going to check mark. And let's see what happens. Simulate. Forgot to view the part. Let's try it again. See how it's slowly getting into the material. And then I should hide the tool. So we can see that there's some um, in the surface quality. We can see that there's like some little inaccuracies, and you can see the steps here. So we can clean this up a bit using a contour pass, because rather than a dynamic milling operation, a contour just focuses, just as like one pass on the contour, so we can go slower and machine it better. Um, while dynamic milling just does the whole face, so it makes sense to use contour as like the finishing pass for these. So we're going to do that. So what we're actually going to do is we're going to go to cut parameters, and we're going to leave 10 thou on the walls, and we're going to leave 0 on the floor. Check mark. And then we're going to do a contour pass. And now we're going to want to select the edges that we want. Do 1, 2, 3, and I think that should be good. And the only thing is we have to go reverse because we're climb milling. So since the tool is moving clockwise like this, it actually has to move this way, other way. So we're gonna actually see if we can reverse that. So now it's gonna go this way. So I think that should be correct. Let's see what happens. So it's gave us a check mark, which is good. And I'm gonna check the cut parameters. So 2D contour, and left is right. So this is based on the direction of the path. Since it's moving this way, left will be this way. So we can compensate in that direction, which is fine. It just means the tool can move in that direction. And we can bleed in, bleed out. And we're using 3/8. I think it's showing good, so we can try this. So now I selected the whole setup, the tool group. So now it'll simulate all of these paths. So we're going to go here, and see it again, and we missed the contour, but we can see that it looks better. We can still see it a little bit, um, but it definitely looks a little better. We can actually go over here, go slowly, and see what happens. And we missed it again, but we can see that there's a difference. So this is after the dynamic milling, and then moving on to the contour, you can see that it smooths it out. Yeah, so I think everything else should be good. Okay, and then now what we're going to do is we're going to add a stock model. Let me just double check something. Yeah, okay. So we're going to add a stock model, which will show the results of this machining operation. So what we're going to do is we're going to do stock model, and we're gonna define it based on the stock model, based on the rectangular part. Um, so we can just actually just redefine it again. So we're gonna, I think this is, yes, I guess this is one way to do it. So we're gonna go bounding box to this, just the same way we define the initial stock body. So check mark, and then we're gonna bring this over here, and so here we have it defined, and then we're gonna actually use source operations. We're gonna say, yeah, so we're just gonna select this whole, all of these toolpaths, yeah, as a source operations, and so it's gonna calculate the, it's gonna use this as the initial stock body, and then it's gonna calculate what happens after these operations. So go check mark, and if we hide this and this toolpath, um, then we can see the results. Should I hide this? Um, let's see. So we're actually gonna, I want to move this part. I'm gonna try this. Oh, okay. So we can see here's the results of our operation. So in the next video, um, we'll do, what we'll do is we're gonna actually use OptiRough to machine it, because we'll see how that's better. Because if we don't use OptiRough, we just hide the stock model. And just for reference, to hide stuff, you do Control T. But what we're going to do is we're going to use OptiRough to machine up to this midplane. So, and then we're going to do the same thing from the other side. So all we'll have left from this front face is to just get this pocket, um, rather than just doing a dynamic milling operation on this, and then another milling operation um, on this contour. The OptiRough will be able to handle doing it all in one toolpath. So we'll see how that goes.